available now in the world of artificial intelligence, because I am the man coming from computers, so I'm more generalized into the artificial intelligence nowadays, because there are a lot of research which is going on in this domain of artificial intelligence. And we are going to talk on the big ocean of machine learning. When you go to any engineering college nowadays, regardless of whether the candidates are learning computer science and engineering or any discipline or stream, you can find easily the projects or the research going on in machine learning, because this has evolved its wings like anything. So we are going to see the details of machine learning. All the researchers which are listening, around 70 odd, are listening to me. You can also capitalize with your research using machine learning techniques. Those are so very handy and so very fruitful. And especially when you talk about the technical justification or scientific justification, these machine learning techniques can help you in a great deal. Say, like, if you have to give some predictive analysis about certain event, maybe rain forecasting or farming or healthcare or something like that. So you need a technical backbone, you need a technical justification that whether your prediction is correct or not. So for that, when machine learning techniques will help you in a great deal. So let me proceed towards this technical topic. I understand this is so very technically complicated topic, but I try to simplify it. So what are the things which we are going to visit in this presentation? We are going to see evolution of machine learning, that where from this came, how machines start learning and what actually it means. And then what are its types, like what is supervised learning, what is unsupervised learning, what is reinforcement learning, and what are various applications of machine learning. And finally, we will wind up the discussion. Yeah, let's go and try to see that where from machine learning at all came in the consideration. What are the evolutions of machine learning? See, this is the white paper which was given and written by J. McCarthy from Dermot College, and he was the first, person who proposed that whether machines can think. Is it possible that machine can think and give the decision on our behalf? Because sometimes when we decide something, it may have error into it, or they may, falter and give the wrong results. So can machine think? So he was the first person who has actually given this thought in 1956. And here he is. This is his photograph. He's sitting in the laboratory and performing the various algorithms which are based on artificial intelligence. So he was the foundation stone for AI and machine learning. Now let's try to learn. Let's try to understand it, what actually learning means. Because once we are clear with the concept of learning, that how we humans learn, then only we can train machine, right? So let's try to understand how we humans will learn. See, when we go to schools, we are given some objects, we are given some pictures, we are given some pronunciations, we are given some experiences, and on the basis of that, we keep on storing those experiences, we keep on storing those incidents in our mind, and we start learning. For example, these are some of the pictures we have. So as a human being, we are told that this animal which is visible is a cat, and another animal of this kind is again a cat. However, their colors are different, their physique is different, their attires is different, but still both are cats. And this body who look likes with four legs, but this is not cat, this is dog. So these are the objects which are shown to us. These are the pictures which are shown to us, and on the basis of that, we start learning that somebody is cat and somebody is not a cat, or somebody is dog. So this is how we learn. Now, if you can talk about the intrinsic grooves of learning, see, it is capturing of images, experiences, thoughts, labels, words, and keywords associated with the incidents which we visit in a day. So this is how learning gets into the humans. Now the question arises over here: if humans can learn from past experiences, what about machines? How they can learn? Is it at all possible that a human can train a machine so that machines start learning as well? So this is the big question. So let's see how machine learning at all will work. So if humans train machine, then it's become possible for machines to learn. But for that, what do you need to do? You need to give the sufficient data to the machine. You need to give sufficient information to machine so that it will give in response the decisions, the opinions, the suggestions which you are looking for. So for that one, you have to load sufficient data into the machines so that it will process that in some model and then give it back to you. So this is machine learning. So say for an example over here, let's consider this example. Say I have over here two mobile phones, which is very old version of the mobile phone, button operated, and very old screen. But then there's another mobile phone which is touch screen and very smart mobile phone. But this mobile phone which is very smart carries higher cost, and another mobile phone which gives the basic facilities of communication and carries lower cost. Now if you can bifurcate these two handsets and the requirements of the users over here, so there are certain users who require the mobiles to be purchased at lower cost with lower features, but there is huge cadre of the people who wants to pay money but wants more features in the mobile phone. So this is what the demand of the future is. Now if I'm a mobile manufacturing company, what should I manufacture? Who will advise me? Where from I get the input and intelligence? So guys, the answer is machine learning. So let's go and discover that how to predict the future's demand, how to predict the future sales and the productivity. So answer is machine learning. So machine learning can be achieved in three ways. There's supervised learning, there's unsupervised learning, and reinforcement learning. So let's try to understand what is supervised learning. See, whenever you have structured and labeled data, say for example, you are having image, and with that image you are labeling that. Suppose you are having an X-ray image of a skeleton, or a X-ray image of a brain tumor, and if you labeled it that this is the image of a brain tumor, then that image can be processed through supervised learning. And fundamental operation through supervised learning which you can do is classification. In few minutes time I'm going to give you the demonstration which will further clarify this concept. Then there is a concept called as unsupervised learning, the next technique of machine learning, because my topic of discussion today is machine learning techniques. So the next technique of machine learning is unsupervised learning. So here the data is unstructured. It is not labeled. It is not in a format which you can process, right? It may be a video, it may be an audio, it may be an image, it may be an animation, something like that. So it is completely unstructured. So you can form the groups of that. You can form the clusters of that. So this is unsupervised learning. And the third type of learning is reinforcement learning, where nothing is known. You're only learning from experiences or feedback. Say like COVID-19, we are not knowing anything, and somebody says that we have to install the mask onto the face, and we adopted that. So this is sort of reinforcement learning where we learn from the experiences and give the analysis. This is the brief chart of machine learning, which has supervised learning, unsupervised learning, and reinforcement learning. See, machine learning can offer you classification and regression. Unsupervised learning can offer you clustering, and these are some of the techniques of reinforcement learning. And these are various algorithms which you can use for your research work, and there are various techniques in them which you can use for your research work to produce the brighter results, the results which are accepted by Scopus, Web of Science, SCI. See, writing research papers are so very powerful, guys. Everybody which is listening me, try to understand this. Writing good manuscripts are very, very powerful. In 2009, there was somebody called as Satoshi Nakamoto. He has written a manuscript, and now we are having Bitcoin, which is causing nearly 50 lakhs one Bitcoin. So this is the importance of writing good research papers. And believe me, you're going to get good research paper from all these algorithms which I've named. We can set separate sessions for explaining all these algorithms. Now let's see a case study that how supervised machine learning can work. Say for example, I want a model who can predict me when I give an object that whether that object is circular or rectangular. So what I will do, I will input the images of circles and rectangles to that model. This model will be trained, it will be learned, and it will separate the circles and rectangles separately. So whenever I'm going to pose a new image to this model and going to ask them that whether it's a circle or rectangle, this training model is going to easily reply me that whether it's circle or rectangle. And how it is done? This is done by using support vector machine algorithm. So there's an algorithm called a support vector machine which will separates all the circles on one side. So this is the classification of circles, and it will separate all the rectangles on other side. So this is the classification of rectangles. And this border between the two classification, categories is called as hyperplane. So this is one algorithm of machine learning which I demonstrated over here, which is called as support vector machine. Then there's another algorithm which is unsupervised machine learning. This is another technique altogether. See, over here I don't have any label. Last time I have label with the images. Let's see this. See, these images are having label associated to them. I written circle, right? I written rectangle. So machine knows about these figures. But over here, in case of unsupervised machine learning, machine doesn't know about these animals, that who they are. So what machine has started doing, it has started keeping the likelihood animals in one category. So this is called as clustering, right? So this is called as grouping or clustering. So all the animals which are belonging to the same category are collected together, are separated together. This is done by unsupervised learning, where we don't have labels, where we don't have keywords, where we don't have suggestive or guiding words which will categorize the input data, but still this input data is clustered and separated from the other data. So here see this example which I quoted, graphical example. Let's consider this is the raw data, the initial data, and using unsupervised learning, I'm separating them in the three clusters of red, green, blue. So you can consider that. Let's consider this is the overall population of a city, but there are some people who are COVID infected. So these are the cluster which is COVID infected patients. There are certain people who are prone to be infected. So this is another cluster which is prone to be infected, and there are some people who are not infected and safe from COVID-19. So for those sort of analysis, you can use unsupervised learning. For all the kind information, I have written a research paper which is already published in Springer Nature, where I have given a predictive analysis of prediction of an COVID-19 patient using unsupervised learning mechanism. So you can go and see it. It's freely available on Springer Nature. So this is another method which you can employ. And these are various algorithms, these are various applications of machine learning which you can use. I know that we have, already explored about supervised machine learning and unsupervised machine learning. But now these are various applications. We can choose some of them to, give the explanation. In these, the traffic analysis or traffic alerts is one of the application where we can predict the traffic, that on a significant road of a significant city, what sort of traffic will be there today. So you can analyze the traffic and give the alerts to your users that you cannot afford to take this path, instead take another path. You can use in social media as well machine learning. You can sort your inbox into two categories: important mail and non-important emails, right? So you can use machine learning over there. For transportation and communication, you can always use machine learning. Say for example, you can program your cars about a significant path, and then you can keep on transporting from that particular path. Then there are product recommendations. Once you are visiting a e-commerce website and purchasing certain things, machine learning always can recommend you what you next can purchase. Virtualized personal assistants, this is another important use of machine learning, where you can take the use of the resources incubated into the machines and do your tasks. Then self-driven cars, you can store the path which is given by GPS, and you can keep on driving your car. Or even you can have a already or completely automated car. There's dynamic pricing, Google Translator, online video streamings, and fraud detection. So there are a number of things which are can be done by machine learning. So if fraud detection also an application which can be deployed through machine learning. Suppose I am a e-commerce website owner, and you are my customer, and you have done some miscellaneous activity or non-acceptable activity earlier. So I can easily identify you, and I can ban you or blacklist you. So you can do this using machine learning. So these are various applications of machine learning. So what is the conclusion? See, machine learning is very demanding technology nowadays in industry as well as for research. Because see, in research as well, if you want to prove your research work so that the people like SCI, Scoopers can accept your paper, you have to give the technical justification to them. And if you're saying that hey, this is the machine learning algorithm which I deployed on my data and I got these results, so they will accept it, because these machine learning techniques are highly recommended. Even industries are using it nowadays with a huge influence. So this is the importance and significance of machine learning. I suspect that I at least touched this topic today at the keynote. So thank you so much for patience listening. I understand this topic is a little technical, but then it was needful to introduce and aware all of you people about machine learning techniques which are getting consumed in the world. Thank you so much everyone for patience listening.